All right, number 9, we're given a polynomial that has a 0 of 5. We want to find the remaining zeros. So we have f of x equals x cubed minus 9x squared plus 33x minus 65. And then 1 0 is 5. So I'm going to put a 5 in my little box. List my coefficients, 3, 2, 1, 0. I have all my terms, so leading coefficient is 1, negative 9, 33, and negative 65. Bring the first term straight down. 5 times 1 is 5. Combine like terms, get a negative 4. 5 times negative 4 is negative 20. Combined, we get positive 13. And 5 times 13 is a positive 65. Combined, and we get 0. This is what we expect. All right, write the resulting polynomial, x squared minus 4x plus 13. Doesn't look like this is going to factor, so we're going to want to do quadratic formula. So negative b, so it'll be a negative 4, so it'll be a positive 4 plus or minus the square root of 4 squared, which I'm going to go ahead and put as a 16, minus 4 times a, which is 1, times c, 13, all over 2 times a, which is 2 times 1, which is just 2. All right, simplifying under the radical, 4 times 13 is going to give us 52. So this is going to give us 4 plus or minus the square root 16 minus 52, all divided by 2. Subtracting 16, that will give us a negative 36. So we have 4 plus or minus the square root of a negative 36, all divided by 2. Run out of space here. This will give us 6i. Square root of 36 is 6, but it's negative, so it'll be imaginary 6. So 4 plus or minus 6i divided by 2. Both these terms are divisible by 2. So 4 divided by 2 will give us 2 plus or minus 6 divided by 2 is 3, so 3i. So my other two zeros are 2 plus 3i, 2 minus 3i. You can just say 2 plus or minus 3i. This question, we want to find all the possible rational zeros. Okay, so from the text, that formula was take your polynomial, which is 33x to the third minus 36x squared plus 44x minus 35. All right, so all of the terms really don't matter. We're just concerned with the last and the first. So the way I describe it is you take that last number, 35, and you're going to be dividing it and all its factors by all the factors of 33. Consider plus and minus also. So all the factors of 35 will be 1 and 35, 5 times 7, and I think that's it. And then the factors of 33 will be 1 and 33, and then 3 times 11. All right, so you're going to take all the factors on the top, divide them by all the factors on the bottom. Now, one thing that will always happen, you will always get all the numbers on the top, all the factors on the top, you will always get those in your list because they will always be divided by 1. That will always happen. So possible zeros are positive or negative. 1, 5, 7, and 35. Then you're going to divide all of those numbers by 3. So 1 over 3, 5 over 3, 7 over 3, and 35 divided by 3. Then we're going to do all of those by 7. 1 over 7, 5 over 7, sorry, over 11. I'm doing this backwards now. So it should be 1 over 11, not 7. 5 over 11. Kind of flip that. 7 over 11. And 35 over 11. Positive and negative of everything. And then lastly, everything divided by 33. So 1 over 33. 5 over 33. 7 over 33. And 35 over 33. Sometimes some of these will reduce, and if they do reduce and it's already something in the list, you don't have to write it twice. But this is the complete list, positive and negative, of all these terms. So I want to find out which one matches. We got 3 choices. First one, we got 35 over 33, 11, 3, and then over 1. 7 over 33, 11, 3, and then 1, 5. And then, so A looks good. No, B looks good because they got the positive and negative. A doesn't.